All right, so 4.3-2, the first thing that I want you to do is pause the video and fill in the first quadrant of the unit circle from memory. Okay, don't worry about the memorize these yet. We'll do that together. All right, let's see how you did here. This is 0 degrees, 0 radians. And you could also have this as 360 degrees, 2 pi radians. This is over 1 up 0. This is 30 degrees, which is pi over 6 radians. And that's the ordered pair, root 3 over 2, 1/2. This is 45 degrees, which is pi over 4 radians, which is root 2 over 2, root 2 over 2. This is 60 degrees, which is pi over 3 radians. That's the ordered pair, 1/2, root 3 over 2. And finally, this is 90 degrees, which is pi over 2 radians, which is the point 0, 1. Okay, so now let's talk about tangent of 30 degrees, tangent of 45, and tangent of 60. I want you to add this to the unit circle facts that you have memorized. So before I just give you the answers, I want to prove that they are what they are. So we'll do tangent of 30 degrees. So here is 30 degrees, and tangent, remember, is y over x, or sine divided by cosine. So I'm going to do 1/2, because that's the sine, the y value, divided by the cosine, which is root 3 over 2. So 1/2 divided by root 3 over 2. 1/2 divided by root 3 over 2. We don't divide by fractions, so we have 1/2 and then we multiply by the reciprocal, 2 over root 3. The 2's cancel when you multiply, or when you simplify, not multiply. Now I can multiply straight across. I get 1 over root 3. We know that we can't leave an answer like that. We need to rationalize by multiplying by root 3 over root 3. So in my numerator, I get root 3. In my denominator, root 3 times root 3 is 3. So the tangent of 30 degrees is root 3 over 3. Okay. Tangent of 45. Tangent of 45 degrees. So let me first actually say, if I asked you what's the cosine of 45 degrees, I'm asking you what's this x value here. If I ask you what is the sine of 60 degrees, I'm asking you what is this y value. If I ask you what's the cosine of 90 degrees, I'm asking you what is this x value. So it's 0, right? So those ones you already know. Now we have tangent of 30 degrees memorized also. Okay, tangent of 45 degrees. So 45 degrees is right here, and it's y divided by x. So root 2 over 2 divided by root 2 over 2. Root 2 over 2 divided by root 2 over 2. Anything divided by itself is 1, so I'm not going to even multiply by the reciprocal there. I just know that the tangent of any 45-degree angle is 1. So what's the tangent of 45? Instead of thinking about root 2 over 2 divided by root 2 over 2, you can just say, oh, tangent of 45 is 1. Finally, the tangent of 60. So 60 degrees is this ordered pair right here. Sine divided by cosine, y divided by x, root 3 over 2 divided by 1/2. Root 3 over 2 divided by 1/2. Once again, we're going to multiply by the reciprocal. So we have times 2 over 1. 2's cancel, and I get root 3 over 1, which is just root 3. So the tangent of 60 is root 3. Okay, so these ones should be fast also. If I say, we have tangents memorized. What's the tangent of 30 degrees? It's root 3 over 3. What's the tangent of 60 degrees? It's root 3. What's the tangent of 45 degrees? It's 1. Now, if I say, what's the cosine of 30 degrees? You might have to think for a second. You might have to say, okay, 30 degrees, the ordered pair is root 3 over 2 1/2. Cosine's the x value, so root 3 over 2. Okay, so next what we're going to do is we're going to use previous lesson, the previous day's notes, to help us with this. It says, given the following information, find the exact value of any remaining trig values not given. So I want to find sine, cosine, tangent, and then all of their reciprocals. If they already give me one of them, then I don't have to list it again. So for example, they already gave me sine as 1/2, so I don't have to list sine as 1/2 again as one of my answers. Okay, so in order to figure this out, we're going to have to draw triangles. Okay, so I'm going to start by saying, what quadrant is my triangle in? And notice it says you have to have the correct quadrant. Also, when you draw your hypotenuse of your triangle, it's always going to be positive. Okay, so I have to think about this. So I'm going to draw a little teeny tiny coordinate plane off to the side so I can think about what quadrant this is in. So this right here is saying the sine is 1/2. 1/2 is a positive number. So sine is positive. Which two quadrants is sine positive in? So I'm going to do all students take calculus. Oops, calculus. So where is sine positive? Quadrants 2 and quadrants 1. So 3 and 4 are ruled out. Now I look over here and see what the other clue is. It says cosine is √3/2. In other words, cosine's positive. So out of these two that I've limited it to, where is cosine positive? Cosine's positive right here. It's also positive down here, but I already ruled it out. Okay? So I'm drawing my triangle in my first quadrant. So I'm going to draw my first quadrant. I'm going to put a point somewhere in that. I'm going to connect that point to the origin. I'm going to connect that point to the x-axis with a vertical line, and then make my right angle. Theta is created by the x-axis and the terminal side. All right, now I'm going to label my triangle. Remember, sine is opposite over hypotenuse. So the opposite side is 1, and the hypotenuse is 2. Now, I might have to use Pythagorean Theorem to get the third side, unless I was given more information that helps me. They also gave me cosine, which is adjacent over hypotenuse. So I know the adjacent side is √3, and the hypotenuse is 2, which I already knew. So I didn't have to do Pythagorean Theorem to figure out the third side. All right, now I'm going to find any remaining trig functions. So I'll start by going in the order that I have them in my head. I start with sine. Did they give me sine? Yes. But I still need its reciprocal. Okay, so you could either do sine, its reciprocal, cosine, its reciprocal, or I can do sine, cosine, tangent, and then all the reciprocals. So I'll do sine, cosine, tangent, and then all the reciprocals. So I have sine. I have cosine. The first one that I need to list is tangent. So tangent of theta is equal to, I need to do the opposite side, which is 1, over the adjacent side, which is √3. So 1 over √3. But remember, I can't leave my answer like that. I need to rationalize it. So that is √3/3. All right, now I need all my reciprocals. So I'll do cosecant next, which is the reciprocal of sine. Sine was 1/2, so all I have to do is flip it. That's 2 over 1, which is 2. So cosecant is 2. Next, I'll do the reciprocal of cosine, which is secant. The reciprocal of this. So I need to do 2 over √3, which I can't leave that answer like that. So I'm going to rationalize by multiplying by √3/√3, and I get 2√3/3. And then finally, I need cotangent, which is the reciprocal of tangent. So I have tangent listed right here. It's the reciprocal of this. But remember, we had to rationalize to get that. So I'm just going to do the reciprocal of the original, which is then just √3. If I did the reciprocal of this, I'd get the same answer. But it's just faster to use before you flipped it. All right, and there is your first problem. So they're all very similar to this. Now, if you look at this one was special because this is from the unit circle. The angle that has a cosine, an x value of √3/2, and a sine of 1/2, a y value of 1/2, the ordered pair, √3/2, 1/2, that's a 30-degree angle. So I could have said, okay, what's the tangent of 30 degrees? √3/3, remember from up here? But they're not always like that. Okay, so what happens when they're not like that? Let's look at the next one, B. So first off, I have to decide what quadrant I'm in. So I'm going to start by saying, okay, here's all 4 quadrants. All students take calculus. All right, so this says sine is 1/3. In other words, sine's positive. So which 2 quadrants is sine positive in? First and second. So it's either going to be in the first quadrant or the second. Then I look for my second clue, and I realize my second clue gave me the answer already. It says the angle's in between pi over 2 and pi. So now I have to know where pi over 2 is. Pi over 2 is right here. We have that up there. All right, pi over 2 is right there. Then I need to know where pi is. Pi is half of a circle. I'm too zoomed in to see where I am. Jeez. Pi is half of the circle, so pi is right here. Okay, so that's saying my angle's in between those 2 angles. So I know that my angle is in the second quadrant. So now I'm going to draw my second quadrant. You can draw all 4 once again, but I just drawing the one I need. I'm going to put a point in there. I'm going to connect it to the origin. And then I'm going to connect that point to my x-axis with a vertical line always. Right angle, theta is created by your x-axis and your terminal side. All right, now I'm going to go back here and see what they gave me. They gave me sine, which is opposite over hypotenuse. So the opposite side's 1, the hypotenuse is 3. Now I look for more information, and that's all I have. So I'm going to have to use Pythagorean Theorem to get my third side. So I'm going to do a squared, which I'll use 1 for a squared, this one right here, plus b squared, which is this right here, and I don't know it, so I'll put plus b squared equals, or you can call it x squared, that's fine, equals c squared, 3 squared. 1 plus b squared equals 9. Subtract 1, b squared is 8. Square root to solve. Remember, whenever you square root to solve, you're doing plus or minus, but since this is a problem where we have to know if we're going left, right, up, down, it's important to do plus or minus. B equals plus or minus. And then the square root of 8 is simplifiable. 4 goes in there twice, so this is plus or minus 2 root 2. So now I have to decide, is it positive or negative? So it's not the radius. If it's the radius, it has to be positive. But if it's a side, I have to decide if I'm going left, right, up, or down. This is towards the left, so this is going to be negative 2 root 2. All right, now I'm going to find my remaining trig functions. I already did sine. Next is cosine. So I need the cosine of theta. All right, cosine is the adjacent side. Let me erase this arrow right here. Is the adjacent side over the hypotenuse. So negative 2 root 2 over 3. So I'm going to put the negative in front. 2 root 2 over 3. And there's my cosine. Notice I don't have to rationalize. Notice 2/3 is not simplifiable, so that's done. All right, next I'll do tangent of theta. So tangent is the opposite side, which is 1, over the adjacent side, which is negative 2 root 2. So tangent, I have 1 over, I'll put the negative in front, 2 root 2. All right, I can't leave my answer like that because it's not rationalized, so I need to rationalize it. So first, before I do that, I'm going to see if my fraction's simplifiable. 1/2 is not, so that's ready to go. So now I'm just going to multiply by root 2 over root 2. And I get negative 1 times root 2 is root 2. And then I have root 2 times root 2, which is 2, but then don't forget about this 2 right here. So 2 times 2, 4. There's my tangent. All right, now I need to do my 3 reciprocal functions. I'll do the reciprocal of sine, which is cosecant first. That's reciprocal of 1/3, that's 3. Now I'll do the reciprocal of cosine right here, which is secant. So I need to flip that, so I still have it negative. 3 is going to go in the numerator. 2 root 2 is going to go in the denominator. Once again, I can't leave my answer like that, so I need to rationalize. 3 over 2 is not simplifiable, so I don't have to do that first, but I'm going to multiply by root 2 over root 2. 3 times, oh, don't forget your negative. 3 times root 2 is 3 root 2. And then this is root 2 times root 2, which is 2. 2 times 2, which is 4. And there's my answer. All right, last I have cotangent, which is the reciprocal of tangent. So I need to flip this, and I say, wait a minute, I had to rationalize here. So let me just flip this. So if I flip that, I get negative 2 root 2 over 1, which is just negative 2 root 2. And there's my answer. All right, 2 more of just practice. So notice after the first 2, it should be, I can try these myself. All right, so we have 2 more to practice here. All right, I have to decide what quadrant I'm in first. So I'm going to use all students take calculus to help me. All students take calculus. So this says sine of theta is 1 over root 5. It's not rationalized, but I can give you something that's not rationalized. You just can't give me anything that's not rationalized. All right, so sine of theta is 1 over root 5. So that means sine is positive. So I'm either here or here, because that's where all are positive, and that's where sine is positive. Now I look here, and it says cosine is less than 0. Less than 0 means negative. So where's cosine negative out of those 2 that have dots in them? Well, everything's positive here, so it's not this. And only sine's positive here, so it's this one. So it's in the second quadrant. So we are in the second quadrant. We're going to draw a point. We're going to connect that point to the origin. We're going to connect that point to the x-axis with the vertical line, and we're going to make a right angle. Theta is created by the x-axis and the terminal side. And now I'm going to label what they gave me. So they gave me sine again. Sine is opposite over hypotenuse. So opposite's 1, hypotenuse is root 5. If I look at my extra set of information, they didn't give me the adjacent side through anything. So I have to find the adjacent side myself. I'm going to use Pythagorean Theorem. I'm going to do 1 squared plus x squared, and you can use b squared if you want, equals root 5 squared. 1 squared is 1 plus x squared equals root 5 squared. Remember, a square cancels out of square roots. That's 5. It undoes it. Subtract 1. I get x squared equals 4. And then square root to solve. Plus or minus, plus or minus. X equals positive or negative 2. It's not the radius, so it can be either one. So now I look to see which one it is. It's going to the left, so it's going to be negative 2. All right, now I can find my remaining trig functions. I already have sine, so next I'm going to move on to cosine. Cosine of theta is the adjacent side over the hypotenuse. The adjacent side is negative 2, so I'm going to put negative and then 2. Hypotenuse is root 5. I need to rationalize this. If you get to the point where you're rationalizing in your head, I'm absolutely fine with that. But when I need to flip it, it is useful to have the original. So I have negative 2 times root 5 is 2 root 5 over root 5 times root 5, which is 5. So there's my cosine. Now I'll do tangent of theta. Tangent of theta is the opposite side over the adjacent. The opposite side's 1. The adjacent's negative 2. So I have 1 over, I'm going to put the negative in front, 2. Here's the tangent. All right, now I need the reciprocal of sine, which is cosecant. So cosecant of theta. And I need to do the reciprocal of this, which is root 5 over 1, which is root 5. Now I need to do secant of theta, which is the reciprocal of this, but I rationalize it, so I'm going to go back to this, and I'll take the reciprocal of that. So that is negative root 5 over 2. Last, the reciprocal of cotangent, the reciprocal of tangent, cotangent. The reciprocal of negative 1/2 is negative, and then 2 over 1, which is 2. All right, last one. Why don't you go ahead and pause the video and try this one on your own. First, check to make sure you have it in the right quadrant before you move on. Okay, so you should get that it's in the 4th quadrant. If you got that it's the 4th quadrant, go ahead and keep going. Okay, so let's do this now to see how you did with all of your answers. All students take calculus. All students take calculus. All right, my first bit of information tells me sine is negative 3/5. So sine is negative. So out of these quadrants, where is sine negative? I know it's positive in quadrants 1, 2, so that means it's negative in 3, 4, because only tangent's positive in 3 and only cosine's positive in 4. All right, now I look at my second piece of information, and it says cosine is 4/5. In other words, cosine's positive. So out of these two quadrants, where is cosine positive? Right here. So I am working in my 4th quadrant this time. Put a point in there, connect it to the origin, connect it to the x-axis with a vertical line, right angle. Theta is created by your x-axis and your terminal side. All right, so the sine is negative 3/5, which is opposite over the hypotenuse. Now, only one of them's negative. To figure out which one's negative, I'm going to label both and then see which one's negative, which one's down or left. All right, so opposite's 3. That's here. Hypotenuse is 5. Remember, the hypotenuse is always positive because it's the radius. So the only thing that could be negative is 3, and if you look, it's going down 3, so that is negative. Now, I can use Pythagorean Theorem to get my third side, my bad. Or I can realize that this is a Pythagorean triple. This is a 3, 4, 5 triangle. Or I could have come over here and said, now I have cosine. This is adjacent over hypotenuse. So the adjacent side's 4, and the hypotenuse is 5. Okay, now I'm going to get my remaining trig functions. I already did sine. I already have cosine, so tangent would be next. Tangent of theta is equal to the opposite side, which is negative 3, over the adjacent side, which is 4. Now I need my reciprocals. The reciprocal of sine is cosecant. Reciprocal of negative 3/5 is negative 5/3. The reciprocal of cosine is secant. The reciprocal of 4/5 is 5/4. And finally, the reciprocal of tangent is cotangent, and the reciprocal of negative 3/4 is negative 4/3. All right.